Hello friends, in this session we will see phasor diagram with the variation of field current. I mean to say with the variation of excitation. This means that definitely we will try to see what are different cases like sort of over excitation, normal excitation, under excitation, etc. And we will try to understand them from those equation point of view as well. Let us begin. Yes, dear. So now let us start with the alternator. If we think of, alternator, definitely because we are trying to say this for alternator first. So let us try to do that. Okay. First case. What happens is, let me consider that this alternator is connected. Let me assume or think of a case where alternator is connected with infinite bus, number one. Just remember these particular things, sort of. Yes. Second is, and it is operating at a lagging power factor, okay. And then let me consider that the steam power input, I mean, you can take it steam or you can take water, you can take any damn input, whether it is hydro, it is thermal, it is anyway nuclear, anything it can be. So let that be input to be constant, let that be input to be constant, correct? Let that input to be constant. And the next thing is important, that my excitation means what? Nothing but field current. Field current is given by if. So let me consider that my if is what? Variable, which is nothing but the field current, correct? Let me consider variable if. Now next thing is what? Just see, let us try to imply something. See, we know that if the steam power input is constant, what does it indicate? It indicates that if my input is constant, if the input to the alternator is constant, this means that the output power has to be constant or not? Yes, this means that my output power, very important statements I'm making now, output power is constant, yes or no? Because input power is constant, no? That is the reason. Simple logic. Now next is what? If is variable. What does that imply to us? If is variable means what? Something has to change in the machine, yes or no? Definitely. Now students say, sir, if variable means what, sir? Excitation will vary, sort of. We will be having, things like over excitation, under excitation, and like, stuff like that. But let me tell you one thing. If if is varied, people actually say this, example, if I think of active power output P, what is that given to be? It is nothing but ef vt by xs into sine delta, correct? Yes or no? Now students say that, example, if I vary ef, let us see here, if I change this if, let's see, if I change if, what will happen? Ef will be changed, ef will change, yes or no? Because if and ef, correct, proportional to each other. Already we have seen this, correct? Because if creates the flux, because of the change in flux, what comes is ef, correct? So now if I think of that my ef is varying, this means what? So now students say that if my ef is increased, this means that, let us say, my output power will increase, example. Then what will happen, sir? Now you please understand one thing. If excitation is increased, does not mean that your output power should increase. Why does that happen? Why? I'll tell you. See, reason is very simple. See, reason is that reason is that when you say that your input power is constant, this means that output power has to be constant, which means even if you increase your ef, then your active power should not change. Then what should change? Then the thing that should change is nothing, and that nothing is nothing but what? Reactive power. We have seen this earlier, correct? Reactive power, which means what? With my variation in the field current, what will change? My reactive power will vary. Understand this. If my if is variable, then my reactive power will change. How that happens, we will try to see that in detail afterwards. Anyways, coming back to our topic. Now one thing is clear, that my steam input is what? Steam input is constant, yes or no? because of which output power is also constant, output active power is constant. And we have seen that since your if is variable, there will be something which will change, that is nothing but the reactive power. So I can say that reactive power is variable. Correct or not? Yes, sir. No problem. We have understood this. Now, let us try to simplify the things for us. Let us see that. See, let us consider this point first. Steam power input is constant, which means output power is constant. Let's try to think about that. When I say output power is constant, correct? What is power P? You please tell me. What is power P, sir? Is it? Can I say that it is nothing but terminal voltage Vt multiplied by Ia into cos phi? Correct or not? For example, if this is your EF, for example, EF at an angle delta, whatever it is, EF at an angle plus delta will be there, correct? Because you are thinking of this. And let me not consider resistance. If I neglect resistance, so let me consider only this excess. And here, this is load. Anyway, this is nothing but plus minus Vt, which is at an angle 0 degrees, and some Ia current flows here this way. Yes or no? So now, what is my output power? See, we have seen that here to here is my synchronous machine, correct? From here to here is my synchronous machine. After that, whatever is there, that will be the output. So if you see here, what is the output? It is definitely what? Vt into Ia into cos phi, and this phi is what? It is the angle between Vt and Ia. Yes or no? Angle between what? Vt and Ia. Yes or no? Yes, sir. Everything fine, no problem. So now you please tell me what happens is, if I think of, when I say, let us understand infinite bus. When I say that it is connected with infinite bus, what does that mean? It means that Vt, the terminal voltage, is constant and frequency is also constant. Yes or no? Because for infinite bus we have seen that Vt and your frequency has to be constant at any cost. At any cost it has to be constant. That means what? Your Vt is constant, correct? And your output power is also constant. Yes or no? What does this imply? What does this imply? This implies that if your power is constant, if your Vt is constant, it means that your Ia cos phi has to be constant. So this is very very important point. The first point we are going to make is what? That my Ia cos phi. Remember this, Ia cos phi is going to be constant. Ia cos phi is going to be what? Constant. This is very important point. Please make a note of this. Correct? Now, we also know some another equation of our power, cylindrical rotor, for cylindrical rotor case. What is that? It is nothing but EF Vt by xs into what? Sine delta. Yes or no? Yes, sir. Now, you please see this. What is constant? Vt is constant or not? Yes, sir. Why? Infinite bus. Same old story. Now, is my xs constant? Yes, xs is constant. Why? Because it is nothing but a machine constant. Correct? Depending on the machine, it will be the reactance of the machine. Correct? It just cannot change with your operating things because it is constant. Now, next is what? Your output power is constant or not? Yes, sir. Output power is constant. What does this mean? This means that my EF sine delta has to be constant. Has to be constant. So this thing also has to be constant, which means, can I write down now that my EF sine delta is also constant? This is very important point. Please make a note of this. So this 2-star point and this 2-star point. Correct? Yes, sir. No problem. Now, what happens now when we say that if is variable, field current is variable? Field current is what? If, correct? If if is variable, then what happens? Definitely ef is going to be variable or not? Yes. So you just keep these 3 points in mind. This 1, 2 and this one, this 3, this third point. That's it. That will solve the entire story. Correct? Let us try to draw the Phasor diagram. Okay, let us see that. Focus, dear, focus. See. Yes. So now let me consider Vt. Let me consider this as Vt. Now, what have we seen? We have seen that my Ia has to be how? Lagging or not? Yes. Why? Because we have already seen that it is operating at lagging power factor. That is what we have decided to do. Correct? So let me have lagging power factor. So Ia will come here. Yes or no? Yes or no? Let me think of it as IA1 because different cases we will try to see, no? That is the reason. Let me consider this as IA1. For time being, you will understand everything. Don't worry. Now, this is VT and this is IA. Now, where will be EF, sir? EF will be where? Left of VT or towards right of VT? Definitely, we have seen that the field poles are ahead of which poles? Resultant poles. In case of alternator, which means what? My EF should lead VT. Yes or no? So my IA axis drop will be where now? Will be where now? Definitely, my IA axis drop will be like this. This 90 degrees to my IA1. So let me just draw that 90 degree from IA1 moving through VT. Correct? So basically what will happen is here this is going to be what, sir? This is going to be IA1 axis, yes or no? IA1 axis because it is with respect to IA1, correct? And definitely VT plus IA1 axis will give you what? EF. We have seen that earlier as well, correct? In case of alternator. So I will be having my EF here. Let me consider this as EF1. Correct, guys? Okay, no problem. Yes, sir, no problem. This is what we have understood, no problem till now. Now let us see what is angle between EF and VT. Definitely it is delta. So let me consider that angle to be delta 1. Okay, let me consider that angle to be delta 1. What is the angle between VT and IA1? What is the angle between VT and IA1? Definitely it is this angle is nothing but what? Phi 1. Perfect of phi 1. Correct? Now look up. If this is my IA1, where will be my IA cos phi? Why I'm interested in it? Because see, I have seen that these 3 points are only important for me, 1, 2 and 3, correct? So the first point, if you see, IA cos phi has to be constant, correct? Yes, sir. So now if my IA is here this way, so how will be my IA cos phi? Let us understand. So if I think of a triangle this way, for example, so what will happen? Definitely now if you see in this particular way, now if this is my IA1, then my IA cos phi will be here or not? Think from your geometry basics. IA cos phi will be here or not? Yes or no? So now my IA cos phi is what, sir? Is definitely constant. Yes or no? So let me consider it as constant. Correct? No problem. Done. Now next thing. This one is drawn. Next is what? My EF sine delta is constant. Yes or no? EF sine delta is constant. Let us draw that here now. So if my EF is here, correct? Then what will happen? Definitely EF sine delta. If I think of this way, this dotted line, correct? Newly drawn dotted line. That is nothing but EF sine delta. So this is nothing but EF sine delta. Yes or no? Correct or not? Yes, this is going to be EF sine delta, which is again we have kept that to be constant. Yes or no, sir? Yes, sir. EF sine delta has been kept constant. Now, now let us think of because delta is here, no? So depending on that, correct? Now, next thing is what? Since IF is variable, my EF is variable. Now, let me reduce IF. What I'm saying, let me reduce IF and see what happens. You please tell me what will happen. If I decrease IF, definitely EF will also decrease. Why? Because they are directly proportional to each other, correct? Yes, sir. Correct. Which means what? EF has to be reduced. But now we have seen that since EF will change, but my EF sine delta has to be same or not? Yes, sir. EF sine delta has to be same. Which means what? Even if my EF changes, my EF will come somewhere here. For example, if I consider that my EF has been reduced here. So this red is, let us say, my EF2. Why? Because what has to happen? EF2 sine delta has to be same or not? Yes. Means this particular thing has to be same. This distance has to be same, which is nothing but EF sine delta. That is the reason my EF2 will not change like this. It should change only the way I have shown. correct or not? That is its way, limitation. Now what will happen? Definitely it's this EF2, now this VT plus IA excess. So here I will be having this, what do we say, IA2 excess, VT plus IA2 excess will give you my EF2, correct or not? Yes sir, done. Now let us see one more case. Now see. Let me consider angle between VT and EF2, because see VT will not change. No, why? Because infinite bus. Now angle between VT and EF2. What is that angle? Angle between VT and EF2. This is red. Let me draw this red. I hope you can see this. Correct? It is nothing but delta 2. Let me consider that to be delta 2. Okay? Yes. Now let me decrease my IF even more such that EF reduces even more and see what happens. Yes. Now, for example, if my EF reduces up to here, let us say, let us consider my EF reduces here. So, let me have my EF. This is nothing but my EF3, if I see, correct? Now, what should happen? VT plus IA3 access will be nothing but EF3 or not? Yes. Which means what should happen? This way. My IA3 access should move like this. So, this is nothing but my IA3 access. IA3 access. Okay, correct? Yes, no problem. Now, what is angle between EF3 and VT? Definitely, it is nothing but delta 3. So, it will even more increase. So, this become delta 3. This is that angle. Correct or not, sir? Yes. Now, what if I even more decrease it and I make my angle delta to be equal to, let us say, 90 degrees? Then let us say what happens. See, if I decrease this IF even more such that my EF3 comes up to here, let us consider. So this becomes what? This becomes my EF4, yes or no? This is my EF4, correct? And definitely, can I call this to be EF minimum? Yes. Why? Because now if you see, the angle between this and this is 90 degrees. This delta 4 is nothing but equal to 90 degrees, yes or no? Yes sir. Since it is equal to 90 degrees, this means that what should happen? What should happen? Definitely it is going to be, after this, if I decrease it even more, what will happen? It will move even more down, which means beyond 90 degrees. Beyond 90 degrees is what? Unstable region. We have seen that earlier as well. Beyond 90 degrees, what will happen? Unstable region, correct? Yes. So let me consider this way. So VT plus what? VT plus IF4 axis is nothing but equal to EF4. Yes or no? VT plus IA4 axis is nothing but equal to EF4. Correct? Yes. Now, let us think of IA. Now, what happens to IA? Let us see. If you observe, what is IA? If my IA axis, now, if you consider IA1 axis, see here, what happens? Let us see. What happens is, for example, let me consider IA2 axis. Correct? If I think of IA2 axis, what should happen? 90 degrees to IA2 axis, I should have my IA2. Yes or no? Yes. Why? Because IA2 axis is what? IA2 axis is nothing but the voltage drop across reactance, and we know that voltage, voltage across a inductor. What does it do? It leads by 90 degrees. Voltage leads current by 90 degrees. Yes or no? Yes. That is the reason 90 degrees to my IA2 axis. 90 degrees to my IA2 axis, I will be having what? I will be having my IA2. Now I know that even if I have IA2, I know my IA cos phi has to be constant, correct? Yes or no? Which means definitely this particular portion, this I cannot change. This length I cannot change, correct? Yes or no? Which means my IA2 will be like this, because IA2 will only come up to this line. Its limitation is only this much. This is nothing but my IA2. Correct or not? Yes, sir. Now, what about IA3, sir? What about IA3? IA3 will be how? Let us see. It will be very interesting for us. IA3 will be again what? What? To this one, to this IA3 axis. To the axis of IA3 axis, I should go how many degrees? How many degrees I should go? I should go 90 degrees lagging, correct? Which means from this IA3 axis, if I try to draw 90 degrees to this IA3 axis, correct? If I try to draw 93 degrees to this IA3 axis, then what will happen? This is 90 degrees to the axis of IA3 axis. This is 90 degrees to IA3 axis, correct? Axis of IA3 axis. Now, what will happen? Definitely 90 degree to this IA3 axis, which means what should happen here? My IA3 will be where? Where will be my IA3? IA3 will be somewhere here. Correct or not? My IA3 will be like this. This is going to be my IA3. I hope you can see this IA3. Correct, no? This is going to be my IA3. Yes or no? Yes, sir. Why? Because I know that whatever happens to my IA, my IA cos phi has to be same. My IA cos phi has to be same. Its magnitude can change. Magnitude of IA can change, but my magnitude of IA cos phi cannot change. Getting my point, right? Yes. Now let us see what happens. This is one. Now let us see another case. What happens now? Let us think of EF4. Let us think of IA4. Where will it go? Where will it go? To this axis of IA4 axis. Whatever is the axis of IA4 axis, let me drop 90 degrees. Correct? This is 90 degree to the axis of IA4 axis. Correct? Since it is 90 degrees to IA4 axis, my IA4 will look how? My IA4 will go this way. This is nothing but IA4. Correct? Not? Correct or not, dear? Please tell me. Yes or no? Yes, sir. IA4 has come here. Correct? This is the overall structure of the same. But what it implies is important for us, is of interest to us. Let us see that. What does that imply? See dear, let us think of reactive power now. So let us think of reactive power. You please tell me what happens. What is reactive power? Reactive power delivered by an alternator. We know that because it is alternator, so we always like kind of think of delivering power. Correct or not? In case of alternator, what do we see? We try to always we think of Q output, or you can say Q delivered. Yes or no? Yes. What is reactive power? Output reactive power of an alternator. In the sense what? Delivered reactive power. So let us see that equation. What is that equation? See, what is that equation? It is nothing but Q output. Definitely because it is alternator. Correct. What is Q output, sir? Q output or Q delivered. Q output or Q delivered. We can also write the delivered. Correct. What is that equation? Which in the last video we had seen the equation to be what for a cylindrical rotor? Vt by xs into Ef cos delta minus Vt. Yes or no? Yes or no? Please tell me. Correct? Yes, sir. It is right. Now, what happens if this particular thing Ef cos delta minus Vt, Ef cos delta minus Vt, correct? Now, what happens if this turns out to be positive? For example, if this turns out to be positive, Ef cos delta minus Vt, then what will happen? It is going to be delivering Q or not? Yes, it is going to deliver Q. Why? Because it is Q output. No, delivered positive. Now, what happens if it becomes zero? What can we say then? We can say that it neither delivers nor absorbs reactive power. Correct? Neither delivers nor absorbs reactive power. Next is what? Third case. Let us see. What is third case? What if Ef cos delta minus Vt is negative? What happens then? If it is negative, it means what? It is delivering negative reactive power. Delivers negative Q. Correct? Can I say that if it is delivering negative Q, so can I say that it is absorbing Q? Yes, I can say that it is absorbing Q. Correct or not? These are the three cases we see. Let us try to apply them in our original discussion. Let us see that. What happens in case of EF1? See, EF cos delta minus Vt, correct? EF cos delta minus Vt. So let us consider EF1 cos of delta 1. What happens? See, if my EF1 is here, this thing, this becomes what? This becomes EF1 cos delta 1. Yes or no? Correct? EF1 cos of delta 1 means this is the whole thing which is there. From this, if I subtract my Vt, if I subtract Vt, what will happen? Vt is less, EF1 cos delta 1 is more. Correct? No? The first case, when I think of EF, if I think of the first case, EF1, what has happened? What has happened? EF1 cos delta is more than Vt. Yes or no? Yes, sir. Since it is more than Vt, what will happen? This particular thing, EF cos of delta minus Vt means EF1 cos of delta 1 minus Vt. This thing will become positive. If this thing becomes positive, then can I say that my output power is positive, output reactive power is positive, which means can I say that it is Q delivered? So it is delivering Q or not? Yes. Now if it is delivering Q, what does that imply? We have seen this earlier as well, that if it is delivering Q, if it is delivering Q means alternator is what? Means synchronous machine is what? Overexcited. Overexcited. That's it. We have seen that, no? Earlier as well. This means that my synchronous machine here, when it is operating at EF1, it is overexcited. Yes or no, dear? Please tell me. Correct or not? Yes. Now, next. Let us consider EF2. Okay. For EF2, if you see, this is nothing but EF2 cos delta 2. Yes or no? EF2 cos of delta 2. Correct or not, dear? Please tell me. Yes. EF2 cos of delta 2. Now, if you see, EF2 cos of delta 2 is same as Vt or not? Is same as Vt or not? Yes or no? Yes. Which means that in case of EF2, if you see, if I think of EF2, so in case of EF2, what has happened? EF2 cos of delta 2, correct? EF2 cos of delta 2. By the way, here it was 1 1, correct? No, Vt is not 1, Vt is always constant, no problem. But anyways, it's okay, even if you don't remember that, it's fine. Yes, EF2 cos of delta 2. In this second case, what have we seen? EF2 cos of delta 2 is same as Vt or not? Yes. Magnitude wise, correct? Yes. So EF2 cos of delta 2 is greater, is equal to Vt, correct? Which means what should happen here? EF2 cos of delta 2 minus Vt should be what? If both of them are equal, which means it is going to be 0. So can I say that reactive power is neither delivered nor absorbed? Neither Q delivered nor absorbed, correct? So in such a case, now if you see, till now we have not at all talked about something called as normal excitation, but now we will talk that this particular condition, when the Q is neither absorbed nor delivered, we say that it is normal excitation. We say that it is normal excitation. Remember this. Normal excitation is when your Q reactive power is neither absorbed nor delivered. That is nothing but normal excitation, correct? Yes. So now this EF2 is what, sir? It is nothing but normal excitation, correct? Yes, sir. Now what about EF3? Again, let us consider the same old story. What is EF3? EF3 is here, correct? So EF3, correct? So I will have, this is what? EF3 cos of delta 3, yes or no? This distance is what? EF3 cos of delta 3, correct? Now here if you observe what has happened, Vt is more, EF3 cos of delta 3 is what? Less, correct? Less. So can I write down for EF3 what has happened? EF3 cos of delta 3 is what? Less than Vt, correct? If it is less than Vt, what does that mean? EF3 cos of delta 3 minus Vt. If EF3 cos of delta 3 is less than Vt, then this sum you will get negative, yes or no? If it is negative, then it means what? It means what? Reactive power is absorbed or not? Yes, reactive power is absorbed from this definition. And if it is absorbed, then what we say? It is nothing but when my synchronous machine absorbs reactive power, whenever it is operated at under excitation. We have Already talked about it, correct? Under excitation. This is under excitation. No, so this means that my EF3 is what? EF3 is nothing but under excitation. Correct or not? Please tell me. Is it right? Yes or no? Yes, sir. This is right. Correct. So this is what we have seen with respect to the reactive power concept. Correct. Now another beautiful observation that we need to make. What is that? Is as I change my field current, EF changes. Yes, sir. If EF changes now, if you see what happens to my IA, what happens to my IA? IA cos phi is constant. I know IA cos phi is constant. Why? Because active power output is constant. But this IA1, if you see IA1 was here initially, correct? Then this became IA2. Then somewhere here I got IA3. Then somewhere here I got IA4. Which means what? From here to here, if you see, it was doing what? It was in lagging condition. Correct? In between it was unity. And again from here to here it became leading condition. Correct or not? Yes, sir. What does this mean? What does this mean? What does this mean? By changing field current, note this down. By varying field current, or in short, excitation, what happens is power factor can be changed. Yes or no? By varying excitation, my power factor can be changed. This is another observation we make from this. Correct? Now, whatever is still left for another, things like, sort of we can think of, let us say, when your steam input is changed, steam power input is changed, and in such cases what will happen, we will try to see them in the next sessions. Stay tuned for the next session. Till then, thank you.